In this topic, the expression for calculating the power absorbed by a circuit is presented. Units used to measure power are discussed, as is the relationship between power and energy. We often need to know the amount of power that is being absorbed by a circuit so that we can calculate the amount of energy that must be provided to the system. Returning to our basic Ohm's law circuit, we can add a further expression, that is, power equals V times I, or voltage times current. In this circuit, power then equals 100 volts times 10 amps equals 1,000 watts. Other rearrangements of the same expression show us that P equals I squared R, and that it also equals V squared divided by R. We have noted here that power is given in units of watts. Often, because of the large numbers involved, it is given in kilowatts, where each kilowatt is equal to 1,000 watts. Where larger numbers yet are utilized, such as in power systems, the unit most frequently used is the megawatt, which is equal to 1,000,000 watts. Power is actually a measure of energy expended over a period of time. In other words, it is the rate of doing work. We could think of power as energy divided by time. Conversely, if we need to calculate the amount of energy being consumed by a particular circuit, we need to multiply the instantaneous power times the appropriate time period. One unit of measuring energy is the joule, which actually indicates the magnitude of power in watts multiplied by the time period in seconds, that is, a watt second. The joule is quite a small unit and may not be convenient in many power installations. Far more common is to use the unit of kilowatt to indicate power and the unit of kilowatt hours, kWh, to indicate energy. Kilowatt hour is derived from the multiplication of power, kW, times the number of hours in the time period under consideration. For example, a load of 500 kilowatts applied for 2 hours would amount to 1,000 kilowatt hours. However, a load of 500 kilowatts over a time period of 30 minutes would indicate an energy consumption of 500 kilowatts times 0.5 hours, which equals 250 kilowatt hours. The distinction between power and energy is very important. Please keep in mind that power is an indication of the rate at which energy is being consumed. This data is useful, for example, when calculating the size of cable that would be required to supply a particular amount of electricity. On the other hand, it would not help you calculate the amount of fuel that you need to have on hand to produce this amount of power.